We're going to be talking about perimeter and area. Perimeter and area. Well, you shouldn't have to remember formulas. That's bad. Okay, what is the perimeter?
The outside of the shape.
Yes.
I think.
What do you mean the outside?
If I drew a square, the lengths of the
The
sides.
outline. How about that?
It's the distance around outside. Yeah, that's what I'm going to call it. It's the distance around the outside.
That's a good looking egg.
Gee, thanks. Okay, so when we look at perimeter being the distance around the outside, I think about normally a yard, or if I'm putting up a fence. Has anybody heard of perimeter fencing before?
Yes,
You put up a fence around the outside of the house, of the property. It protects your house on the perimeter, on the outside, right? So it's the distance around the outside. So if I were to translate that into this room, if I were to want to put up, say, some of that cute brick wallpaper that everybody's putting up in their classrooms now. You know what I'm talking about? It looks like real brick on the inside. Who wants real brick on the inside? Anyways, I don't know. But if I wanted to measure how many feet of that paper I would need, I would count how long it is along my walls, right? And that's how many feet I would need to buy. So let's talk about the different shapes. If I were to have a rectangle that has a length L and a width W, how could I find the perimeter of that rectangle? That is an L. It's a cursive L. How would I find the perimeter of that? I would add what? Well, yeah, that's what I'm wanting to find is the perimeter.
Length and width.
I would add the length and the width. And that'd be finished?
No, not just the length. You gotta add the other side.
Well, what's the other sides?
Well, you gotta add the other part of the length and the other part of the width.
So there's another length and another width? Absolutely.
Yeah.
There are two lengths and there are two widths. Okay. So we could add length plus width plus length plus width, but that would take a little bit longer, actually. If you just multiply the length by 2, the width by 2, and add them together, that's going to be the quickest way to get that perimeter for a rectangle. Now let's think about another shape. Oh, I don't know. A square. It's a great square. What is the length of a square, one of the sides? Say I know one of the sides is length S, and I want to know the perimeter of that square. Absolutely. The perimeter there would be 4 times that side length, S, because every side is going to be S, because it's a square. Okay, now we've done a rectangle and we've done a square. Let's also do a parallelogram. What's a parallelogram?
Is a special type of shape. It's parallel to each side. Yeah, it's like that.
Well, what word do you hear in parallelogram that's a word you... so what is... yeah, gram. Yeah, parallel. What does parallel mean?
They are the exact same.
Two lines that never intersect, that have the same slope, if you talked about slope any last year, right? Those are parallel lines. So a parallelogram has opposite sides that are parallel. You agree those are parallel? Uh-huh. Do you agree those are parallel? Uh-huh. So that's a parallelogram. Okay, for parallelograms, they have a base and they have a side. We're going to call this side A. All right? And a lot of parallelograms will also have a height given to you. So say they draw a line straight from the top to the bottom and give a height h. Now, if I were to find the perimeter of the parallelogram, one of those values doesn't matter to me.
It's the A, ain't it? I think.
Okay? Think about what perimeter means. Perimeter is what?
Round.
It's around the outside.
So it'd be H.
So which one of those is not around the outside?
H.
The H. So in this one, the height doesn't matter. Okay? In this one, the height doesn't matter. And what would the perimeter be? There would be 2 length A's and 2 length B's. That's very similar to your rectangle formula, right? Because did you know a rectangle is a parallelogram?
Yes.
Because to be a parallelogram, what has to happen? Opposite sides have to be parallel. Well, that's true for a rectangle. Okay? But are all parallelograms rectangles? No. What does this not have that a rectangle must have? Right angles. Parallelograms do not have to have right angles. So that's the difference between them. All right? So again, it looks very similar to the rectangle formula. It's because a rectangle is one of these. All right? It is a parallelogram. All right? And then one more. Yes, another one. Thank you, DJ Khaled. Okay. I've got a triangle. And let's say this triangle has sides A, B, C, and it also has a height H. How can I find the perimeter of this triangle?
A plus B plus C.
Absolutely. A plus B plus C. You add the 3 sides. Please know how to find a perimeter from this day forward. I can't ask anything much easier than to find the perimeter of a 2-dimensional shape. You add up the sides of the outside. Now, the next thing we're going to talk about is area. Area. No, we're not going to Area 51.
Why not? Can that be a school field trip?
No.
Why not?
I can't go. My mom is
Good. You should never want to go to Area 51. Now,
People die there. That's the point.
area. Again, everybody's going to hear this. Area. What is the area? If you had to define it.
The inside.
What about the
Inside
inside?
of the perimeter.
The total area.
The area is the total area. Yep, good. Okay, so nobody's got a definition.
It's the inside of it.
That's the way I said that.
Yeah.
What do you mean it's the inside?
It's the inside.
Here we go. Here's my shape, right? Here's the area. I'm inside of it.
I mean, you're totally inside of it. It's all the gray part.
It's all the gray part.
Whoa.
I like that. It's the measure of the how much you're covering, right? That would be the area. So I like it. So the way that I talk about area, I like to say it's measured in square units. Look like a square to you? That looks like a square to me. Okay, so okay, so these don't fit perfect because I'm human. Okay, well that's fine. I'll fix it. If that's the way we're gonna be. So I've got 1, 2, 3, 4 across, and let's say I had 3 down. That's perfect. It is a rectangle. That's a good call. That's a great call there.
Go ahead.
Shh. There we go. Okay. So, say that I've got this rectangle. And what is the distance across? Let's say that it is 4 units. No, across is just 4. Let's say each one of these is an inch. Okay? So the distance across here is 4 inches. And what's the distance along the side? 3 inches. So I've got a 4 by 3 rectangle. And now I wanted to know how many squares that are an inch by an inch can I fit in there? Well, how did you get that? You multiply. If you multiply the length by the width, you get 12. But did you know that we call them square inches because they're literally squares? Edit. Copy. I think I made one too many. No, I did it perfect. So you'll see, I created how many squares that were 1 inch by 1 inch?
12.
12 of them that fit on the inside. So this is 1 inch by 1 inch. So how many square inches are inside this rectangle?
12.
There are 12 squares that are an inch by an inch. Okay? So we would say this is 12 square inches. You seen that before?
Yeah.
Hopefully you've made those little diagrams yourself about area being on the inside. Okay, good. I just want to make sure you've seen that. You had an idea of what we're doing. We're fitting squares on the inside. Now let's look at the different shapes that we'll be dealing with here. So we just did a rectangle. If I have a rectangle that is something like that, and say this is the length and this is the width, what would be the formula for the area of that rectangle? Length times width. If I had a square, and I knew that a side was S, what's the area of that square? It's S times S, or what's a different way I could say that? S squared, huh? I wonder where that comes from, being squared. And now you're getting square units. That's the whole point. Huh? No, that's the truth. That's not a good one. That's not a joke. That's where squared comes from. Okay? What about a parallelogram? I think it's one R. Parallelogram. I think it's one R. I'm looking it up. It's one R. Cha-ching. English skills on point. Now, if I drew a parallelogram, and this was B, and this was A, and this was the height, H, How could I find the area of that parallelogram? It is B times H. It is the length of the base times the height of the parallelogram. You did get it mixed up. It's okay. We all still love you and forgive you. Okay, now, everybody but Griggs. Now for a triangle, if I had a triangle drawn here, and this was A, and this was B, and that was C, and this was the height H, how could I find the area of a triangle? So it's the same as a parallelogram? It's like exactly half of the base times height. Okay? What? Well, let's that's a good question. Let's do a different example. Let me draw a special triangle that makes it very easy to see where that comes from. So say that I were to draw a right triangle where this is the base and this is the height. Let's say I were to draw a rectangle. Oh, not a very good rectangle. That had the same base and the same height. What's the area of this rectangle? BH. What's the area of this triangle? And where does half come from? Do you agree it's half of that rectangle?
Yes.
If I were to take that rectangle and cut it in half, I could fit half as many in there.
Oh.
That's where it comes from. It's half of it. So it's, if you imagine, if I could take this triangle and I could draw another one just like it. Oh gosh. That's not very good. There we go. So that's the same triangle again, right? Just turned differently. You see how it's a parallelogram. It's half of the entire rectangle. So while the parallelogram is height times base, for that triangle it's only half of that. So that's where the half comes from. We didn't just add it in there to make you think, oh, well, I got to memorize a half because these mathematicians will make it hard. God, there's some mean people. I love this question. It's got great timing for us here in this class. The dimensions of a college football field are 360 feet by 160 feet. What's the perimeter of a college football field? So what would we want to know the perimeter for of a college football field? I don't know. Put a fence around it. Since you know we need a fence around our football field because there's no fence around. Okay, so if we're finding the perimeter here, we could do that to find how much fencing I needed to buy. So I like to draw a diagram of what's happening. So since we're outside, I'm going to use green. Yeah. Now, we know the dimensions are 360 feet by 160 feet. And it asks to find the perimeter, P. Yes, Reagan. You just know the answer? You just want to show off? Okay, how could we find the perimeter of a rectangle?
Length times width.
No.
Oh.
That's the whole point. That's the whole point of this lesson, is to know which one is which.
I know.
That's why when I see perimeter, what am I thinking? Perimeter fencing. Y'all said y'all heard that before.
The outline.
You've ever heard perimeter fencing, automatically think I'm putting a fence around the outside. That'll help you keep them straight. Have some way to keep them straight. You can go get a calculator. So what would the perimeter be? Well, there's a couple of different ways you could do it. The shortest way is to do 2 times the length plus 2 times the width. And that would be 720 plus 320, 1,040. And I want you to put your units on every one of these. Feet. That way you can keep it straight between square feet and feet. When it's perimeter, you're just going around the outside. We're not filling in squares on the inside, right? So it's not square units. It's just regular feet. Okay, some of you other ones, you may have just added all the sides, right? 160 plus 160 plus 360 plus 360. That works too. Okay? Any questions on that one? Now we're going to let you do one. And some lucky person is going to get the dice rolled on them. Yes, very good, Ty. Since it's a square, all the sides are the same. So they're all 4. Oh, wow, that's not us. So, it's 4 and 4. So that means... Oh, I'm still using the eraser. 4 and 4 on the sides. Thank you. So that gives us a perimeter of 16. And what did you say it was? 16 meters. That's correct. Yeah, because I didn't say or anything. Make sure you put the unit. Okay. Number 2 tells me to find the area of the parallelogram. Area of the parallelogram. So I know that the area is going to be equal to the base times the height. So what's the base here? 12. What's the height? 4.5. So if I multiply 12 times 4.5, 12, 24, 36, 48, and 6, 54. And then remember, when we're doing area, those are in square inches. Now, it's not always inches. It depends on what your original units are. So in this one, of course, it's inches. Now, number 3, find the area of the triangle. So when I'm dealing with a triangle in area, I have to remember there is a 1/2. All right, what's the length of the base? 9.6. What's the height of the triangle? 5. So when I multiply all those out, 9.6 times 5 is 50 minus 2, 48. Half of 48 is 24. And those will be square meters. Now, if you want to, for square inches, you can write inches to the second power. And for square meters, you can write meters to the second power. Just don't write both. Don't write square meters squared. Or square inches squared. All right? That's repetitive. But those mean the same thing. So I want to make sure you'd seen that before. Okay, let's look at these 2 answers. On B, when you multiply that out, you should do 6.5 times 6.5, correct? And when you do that, you get what? 42.25 square centimeters. Or centimeters squared, because we're doing area now, right? So we're finding how many little squares can fit inside. So this one is correct. 42.25 square centimeters.
I didn't put square.
Oh, you want to come fix it? On C. C is a triangle for the area. So for area of a triangle, remember we have to use 1/2. So Hannah did that correctly. 1/2 times the base, which is 7, times the height, which is 5.3. We multiply all that out. Hannah got 18.55 square miles, and that is correct. 18.55 square miles or miles squared, either way. Any questions on those?